Okay, we're going to take a look at problem 226, which actually uses the illustration from 218, which is on page 35. So we're going to start by drawing a diagram of the area of the forces that are identified here, and they're going to have their common point in the middle here at the 0, 0 of the X and the Y. So what I've done is I've gone ahead and I've drawn my X and Y coordinates here. I'm going to add my convention in the upper right-hand corner. Remember, you need to do this, otherwise you lose a point on each one of your problems. So make sure you add the convention. Now, the first one that I'm going to do here, I've got 60 degrees or 60 pounds at 25 degrees. So I'm just going to draw this about like that. Okay. And that's 60 pounds. And this is 25 degrees. Then I have 40 pounds at about 60 degrees. So a little bit shorter coming down this way. This is going to be 60 degrees, and this is 40 pounds. And then lastly, I've got 50 coming from this way, from the Y. A bit more than 45, right? Okay. And then this one's going to be 50, get a little bit longer. This is going to be 50 pounds, and this angle is 50 degrees. So this is my positive X, my positive Y. Once I have these in place, gosh, is it hard to read the screen here? Yeah. I thought if I put the lights out, it would be better. Because my lights are on here. Maybe I'll zoom in. How does that? Is that a little better? Oh, I'm not on my screen. Okay. So I've got my 60 up here. So I'm gonna, I don't know what I can do here much more than what I'm doing. Okay. All right. So since all three of these forces are not on the X and Y axis, I need to get the components for each one of those. So I'm going to have to call, something X and Y. So I'm going to call this force A. Okay. I'm going to call this one force B, and the 50 force C. Okay. Just being arbitrary. You could call it F1, F2, F3, whatever you want. Okay. And then I'm going to draw my X and Y components for each one of these. So this is going to be AX, and then going across here. This is going to be AY. Then I'm going to have my 40. This is going to be BX. And going down, my BY. Then I'm going to have my CX and my CY. There we go. Okay, so all of them clearly labeled, right? I'll give you a chance to catch up. So this is always your first step when we're doing the rectangular component, to find the resultant when we've got, 3 or more forces. When there's 2, it's a little bit easier to use the sine, the cosine laws. But when we start getting into 3s and 4s, the rectangular component method is really, I think, the best approach. So we're going to do our diagram first. Then our second step is going to be components. Okay. Components. And now what we're going to do is we're going to solve for AX, AY, BX, BY, and CX and CY. Okay. Now, since we know the angle for each one of these, I'm going to start with my A, right? So AX is going to be equal to, the angle that I'm given here is 25 degrees. So my AX is the side adjacent, right? So the side adjacent means I'm going to use the cosine of 25 times 60. Because we know what A is, times 60 pounds. Make sure you put your units in there. Zoom in here a little bit. Okay. So that means my AX is going to have 25 cosine, so 0.9063, well, times 60. So a total of, we'll multiply those two together, 54.379. I'm going to hold 3 decimal places, and that's going to be pounds. Okay. Now we're going to do our AY is going to be equal to, it's the side opposite. So it's going to be sine 25 times 60 pounds. So our AY, 25 sine 60 times, we're going to get 25.3571 pounds. And again, I'm holding just a couple more decimal places so that I'll just round my final answer. Okay. Now we want to do that for BX, BY, CX, and CY. So I'm going to go ahead. I'm going to do my BX. It's going to be the cosine of 60 degrees times 40 pounds this time. I got 20 pounds for BX. BY is going to be the sine of 60 times 40 pounds. So that'll be 34.641 pounds BY. And then I need to do my CX and my CY. Now CX gave us the 50 where it's at. So you have a choice. You could either use the 50 here. Some people like to always use cosine with the X's and sines with the Y's. So you have to put it in this position then. So this, to get to 90, this is going to be 40 degrees then, okay, at here. So it gave us 50 down here, but 40 to get it in that standard position so that our cosines can be for our X's. And I'm going to do that. So I'm going to say cosine of 40 degrees times 50 pounds for my CX. So that'll be 38.3022 pounds. I'm holding the decimal places. And then my CY is going to be sine of 40 degrees times 50 pounds. So my CY, 32.1394 pounds. Okay. Oopsie. There we go. So those are all the components. Okay. Got them all there? All right. Now notice on here, I did not put positives and negatives because my positives and negatives are going to come from the direction. Good night, Brooke. Mm-hmm. And we're going to compare it to the convention that we have here. Okay.
Sorry, did you ask was optional?
It is, yes. Mm-hmm.
Thank you.
You're welcome. So now that we have all our components here, we want to sum our forces in the X and Y to get the resultant X and Y's. So I'm just going to start a new page. And my next step here is I'm going to sum my forces in the X direction to get the resultant X component, not Y, X component. Okay. So when we go back over to our illustration here, we look only on the X-axis, okay? So I've got a negative CX because it's going to the left, okay? It's pointing to the left, so according to my convention, it would be negative. I've got a positive AX and a positive BY. So I'm going to say positive AX, positive BX. And then that's going to be equal to my resultant X component. There we go. And now I know all those values. So I'm going to look at my values and the X here, and I'm going to put them in. So I've got negative 38.3022 pounds. That's my CX plus 54.379 pounds plus 20 pounds. It's going to be equal to my RX. Hmm. So do you get 36.0768 for your RX? Same number? Okay. It's a positive direction, or it's a positive value, so that means it's going to be pointing to the right when we draw our diagram. So we're going to kind of sit with that one for a little bit. We'll put a cloud around it. Now we're going to do the same thing in the Y direction. So sum our forces in the Y direction are going to be equal to our resultant Y. So now we're going to focus just here. Okay. Yes.
So why couldn't we, in the beginning, when we're setting up our components,
Mhm.
is it okay if I put like a positive or like a negative next to the end? Or
I'm gonna
just
say
to-
no.
just
I'm
to
gonna,
show like the direction I think
right.
it's going?
I understand what you're doing there. So you're saying down here, is it okay to put the positives and the
Yeah,
negatives?
like next to the answer to no in my brain, like, oh, this is going in this spot, this is good, like the direction of it.
That's okay, but just remember that you don't want to add in any positives or negatives
No,
when you do this. Do you know what I mean?
Yeah.
Because this is setting, okay, I know what you mean.
Parentheses,
Yeah, that's okay. That's okay.
see that?
That's okay. Yeah.
Okay.
All right. So I have a positive AY because it's going up, minus BY minus CY is equal to the resultant Y component. And again, and that's dictated by the AY is pointing up, BY is pointing down, CY is pointing down. So those are the negatives. So now I'm going to use my values that I calculated, my Ys, and I'm going to put them in. So 25.3571 pounds minus 34.641 pounds minus 32.1394 pounds is equal to that resultant Y component. And then now we just add and subtract. Looks like I'm getting, first time through, I didn't check the numbers, negative 41.4233 pounds. Did you get that number as well? Awesome, perfect. And that's my check. So the negative tells me that this is now pointing down, okay? So the final step here is to calculate the resultant, okay? So we know that we're gonna be in the fourth quadrant, all right? Because we have a negative Y, but we have a positive X. So I'm gonna draw kind of my coordinate system here so that I would be in the fourth quadrant, okay? So I've got X and this would be negative Y. So I know that my negative Y, RY, again, going down because of the negative value that we got, 41.4233 pounds. And then I've got about here, maybe just a little shorter. If I made it any shorter, our X, they're pretty in the ballpark. 768 pounds for RX. You have to draw this diagram, okay? Because it tells me that you understand the numbers that you just calculated. All right, and then now we're simply going to draw our horizontal and our vertical lines through the endpoints to find that intersection. And my resultant's tail is going to start at that origin, and the tip is going to go to the intersection of those two. Okay. And then I'm going to label the angle theta from the horizontal. So the two things we want to calculate here then are going to be the magnitude of the resultant and that angle theta for the direction. So the resultant, because this is a right triangle, my resultant is equal to the square root of Rx squared plus Ry squared, right? Pythagorean's theorem. So under the radical, we're going to have 36.0768 pounds squared plus 41.4233 pounds squared under the radical. So my R is equal to You get 54.9
Is it Plus 41.4.
plus, yep, it's underneath the radical, it's Pythagorean's theorem.
Okay, yeah.
Yep, because we've got the two legs and we want to find the hypotenuse, yep. 0.3. Okay, I'm gonna do it again, but that's what I got to start off with. Got it again, okay. Pretty sure that looks like a good number, 54.94 or 0.93. So that's our magnitude, but to fully define a vector, we have to have both magnitude and direction. So I've got theta labeled here. And so I know the two sides of the triangle, so I'm going to use the tangent. So I'm going to say tan theta is going to be equal to side opposite is my ry divided by my rx. So my ry is 41.4233 pounds divided by 36.0768 pounds. Pounds cancel. $48.95. Yeah, that sounds right. And I'm gonna take a peek because I don't know what the answer is. Let's see. We go here. This was 26, right?
Yeah, 48.9 and then 54.9 is what they have.
Oh, the 50, I don't know I'm gonna check this. So
Oh, yeah.
yes, we're good on the angle and 54.9. Perfect. Yeah. Yeah, looks good.
When you're doing some of the components, when you go down to like minus CX plus AX plus BX, do I have to write it out as that before I go down to the?
Oh, do you mean can you start here?
Yeah.
That's okay. That's okay if you start there. It is. I like to put it so you know exactly what I'm looking for, but as long as I can kind of see, all right, from your diagram, CX is here and it corresponds to this. Yeah, I'm okay. Yeah, so if you wanted to start at this level, yeah. What do you mean?
Because they only took the answers from like.
Oh, because you had your components,
Yeah.
right? I would encourage you to make a diagram like this, and then you can just say AX is equal to, BX is equal to, CX is equal to. You don't have to show the work because you did it in 218.
Okay.
Yes, good point. Yep. Yeah. Any other questions? So diagram, components from 218, sum the forces in either direction, and then your final resultant. Okay.